Hello everyone. So in this particular video, we are going to see a very common and very frequently asked question that is related to corona loss in power systems. Okay. These are the questions that I will discuss in this particular video. Like first, I will discuss what is corona loss, what is the reason behind that, and what are the factors that increase the corona loss, and how does bundling conductor reduce the corona loss, and what is corona ring. Okay. So first, let me explain you what is coronal loss. Okay, uh, in power system network, if you take transmission lines and all, those transmission lines basically operate at very high voltage. That operating voltage of long transmission lines varies from 220 kV to you can say 765 kV roughly. So in this range, you will be having the transmission line voltage levels and all. Okay, and because of this high voltage transmissions, we get the coronal losses and all. And I will explain you how these things appears in that high voltage, extra high voltage, and ultra high voltage transmission lines and all. Okay. Now, this is basically a natural phenomena, you can say. Basically, if you see the overhead transmission lines, just let me draw one conductor. Let's say it is a conductor that is part of a transmission line, and that transmission line carrying the voltage in between this 220 kV to 765 kV. Even it is not strictly in this range, but somewhat you can say at higher voltage level you are transmitting the powers and all. Okay. So let's say you are transmitting the powers through this transmission line. It is a, let's say it is a transmission line for you, and the power is coming from here. Let's say you have some source. Let's say you have some transformers here, and here you have generators and all, and you are transmitting the powers through this transmission lines. Okay, and let's say this is a phase A. So in three phase, you'll be having phase A, phase B, phase C. So just take one phase, and this phase voltage with respect to neutral. So let's say it is a VAN. Okay. So this is the per phase voltage. Let's say uh, we have something called critical disruptive voltage. What critical disruptive voltage means? It is the minimum line to neutral voltage or minimum phase voltage that is required to ionize the uh, air that are located in the vicinity of the conductors. So basically, in overhead transmission lines, around the overhead transmission line, there will be fluid, like air is also fluid, like so. Air will be located around the vicinity of this, you can say, the conductors. So the minimum voltage that is required to ionize the air that is in the vicinity of the conductor, that is something we call critical disruptive voltage, VC. Okay. And and you are transmitting the power at high voltage level, and let's say your per phase voltage VAN is greater than or equal to the critical disruptive voltage. Then in that case, what will happen? The air that is located around the conductor or high voltage transmission line, that will get ionized, and because of that ionizations, the air will behave as a conductor, because air is a dielectric medium, you can say, and it has a dielectric breakdown voltage also. Beyond that, if you increase the voltage level, the air will get ionized, and the air will behave as a conductor. And in that case, there will be various phenomena, like you will be getting some hissing noise from the, you can say, transmission line. You will see some kind of violet colors that is coming from this, you can say, this particular area. So basically, because of this a dielectric breakdown of the air, your electrical energy converting into light energy plus your electrical energy is getting converted into sound energy. Okay. And this to energy conversion is happening because of ionization of the air. So your electrical energy is getting converted into light and sound energy, which is not an electrical energy. Okay. So it is not useful in our case. So basically I am supplying electrical energy from this end, but somehow here I'm losing the energy in terms of either light or even in terms of sound. So in that case, I am having power loss. So that is basically coronal loss. Okay. And air is a dielectric medium, and air has a dielectric breakdown strength or the electric maximum voltage that air can withstand without having any ionization and all. It is roughly around 30 kV per centimeter. So if you have the electric field generated around the conductor is more than or equal to 30 kV per centimeter, then your air will get ionized, and there will be losses in terms of, you can say, light energy, sound energy. Okay. And the coronal loss will happen. And I need to mention a few more points here. Like if you have a line charge, let's say if you have a line charge, let's say it is a line charge, let's say this line length, the length of this conductor and all let's say infinity, and the line charge density, let's say rho L is equals to the it is the line charge density, you can say. It is measured in coulomb per meter. Okay. You have this conductor, this is the line charge density, you can say. And if you calculate the electric field at any point, let's say r, or maybe let's say point at rho point, then the electric field from the conductor, from the, it is basically given as rho L by 2 pi epsilon rho. Okay, this is the magnitude of the electric field getting generated from the line charge, and this line length is infinity. Okay. And if you consider let's say this is your conductor, let's say, okay, it is infinitely long, let's say it is infinitely long, it has a radius r, and I am calculating electric field at any point rho. Okay, so this is the formula, you can say. And if you calculate the electric field intensity at the surface of this conductor, you can say, you can just put rho equals to r, because at surface the rho and r are the same. So electric field E is equals to rho L 2 pi epsilon r. Okay. So you have this electric field created and in the you can say on the surface of the conductor. And if this electric field is, the unit of this electric field is basically nothing but voltage per meter. Okay. And if this electric field is more than this you can say the critical value of the uh, or you can say the dielectric the electric field that is required to ionize the air, this is the this much electric field is required to ionize the air. If you are getting more electric field because of the high voltage transmission, then your air will get ionized, and it will like it will cause a coronal loss, and you will get this sound and this light energy and all. Okay. And from this particular formula, you can see your electric field created around the vicinity of the, you can say, conductor is inversely proportional to the radius of the conductor. Okay. So if you keep increasing the radius of the conductor, then the electric field at the surface of the conductor will reduce, and in that case your coronal loss will also reduce. Okay. So by increasing the radius of the conductor, you can reduce the electric field, and you can also reduce the coronal losses and all. Okay, I hope in this discussion it is clear why this corona is happening, and how this corona loss is related to electric field, and how it is related to radius of the conductor. Okay. This is the point that are required for the discussion of the upcoming questions, like what are the factors which will increase the coronal loss. So let's say if you have this transmission line, and the transmission line has a very like the radius of the conductor is, let's say, very small. In that case, the electric field that will generated at the surface of the conductor will be very high. So in that case you will be having, you can say, more coronal loss. Okay. So this is the case, like you have to increase the diameter of the conductor, then you can say the coronal, you can reduce the coronal loss. So let me write a point: by increasing Like, what is the question? Increase the coronal loss. What is the factor that which increase the coronal loss? Like, by increasing radius, we can we can reduce the coronal loss. Okay. Now, also there is one more point. Like, if you use a smooth conductor, then in that case also your coronal loss will reduce. How it will impact? Let's say you have some kind of rough surface. Let me take some worst case scenario. Let's say you have some conductor like that. Okay. And this is, you can say, it is not a smooth conductor. It has some rough surface here, and here is some kind of roughness you have, and there you have the smooth. Okay. Now, if you see this particular uh, small section, i- the radius of the curvature, you can say it is small. So because of this roughness, the effective radius of this particular radius of curvature is so small compared to the this solid one. See, the radius of the curvature is much larger compared to this small circle, you can say. So in that case, what will happen? You will be having more electric field generated in this particular area, or you can say you will be having more charges accumulated in this particular area, so you will be having more electric field in this area, and your coronal loss will increase. Okay. So just by having a smooth surface of conductor, you can reduce the coronal loss and all. And third point is, it depends on the weather. Like, if it is rainy season and all, in that case there will be moisture and all, so in that case your coronal loss will also increase. So it depends on the weather also, you can say. So these are the main 3 points you can remember, or you can mention, like how, what are the factors that is increasing or decreasing, you can say, the coronal losses and all. Okay. Yeah. And and how does bundling conductor reduce the coronal loss? See, bundling conductor is simply increasing the effective radius of the you can conductor. So what is bundling? Let's say you have one conductor per phase. Let's say you have transmitting power and through one conductor, it is a phase. So bundling means you can, let's say you can transmit the power. Let's say you have a phase, but in a phase you have four conductors. Okay. So this four conductor will carry the power for the A phase. So in that case, what will happen? Your the overall radius or overall diameter per phase will increase, and as we know, the electric field is like inversely proportional to the radius. As the radius is increasing, the electric field will reduce, and the coronal loss will also reduce. Okay. So coronal loss will also reduce. How things are happening here? Let's say you are having let's say you have this conductor. Let's say you have this plus q charge of this per phase, and that q charge will simply distribute it into four conductors, q by 4, q by 4, q by 4, q by 4, like that. And in that case, what will happen? Charge per conductor is reducing, and you can say the congested area of the charges, because if you have this, instead of having one conductor, if you have four conductor, basically the charges are located on top of the conductor, and they all these q charges are congested in a particular area. So electric field will the strength of the electric field that will create because of the single conductor will be very high. But in that case, what is happening here, the total q charge is distributing along among the four conductors, and you have the less congested or less crowded in the charge, in terms of charge over the conductors. So in that case, you'll be having the strength of the electric field will also reduce, so coronal loss will simply reduce. So bundling conductor is simply reducing the coronal loss by increasing the effective radius, you can say. Okay. Now, what is coronal ring? So this particular picture, you can say this one is basically your coronal ring. And what is happening here, basically this is your it is rings are this coronal rings is directly connected to the lines. And what is happening here, the ring is basically distributing the electric field. So in that case, here you can say this rings is behaving as a conductor because it is connected to transmission lines or conductor itself. So your effective area is increasing here and electric field is simply distributing here. So in that case, your corona losses and all will also reduce. So you can you can say that by increasing the corona ring, you are distributing the electric field that was initially it was congested, but now it is distributing. Now you will be having less coronal loss and all. Okay, so these are the main points regarding coronal loss. So I hope it is clear, like what is coronal loss, what are the factor it will increase the coronal loss, how to reduce the coronal loss by using bundling conductor, and how to use the the corona rings and all.